Okay, let's move on to problem number 19. For problem number 19, we're asked to find the length of AD. All right, so let's look at this. AD is this line segment from here to here. And we've got to think about this for just a second. If this is perpendicular, then this is perpendicular. If this is 30 degrees, then this has to be 60 degrees. And if that's 60 degrees, and this is 90 degrees on this side, and that's 60 degrees, then that means it's 60 degrees here, or 30 degrees here. So these are congruent. So now what I've done is I've just informally proven that that's an isosceles triangle. And on an isosceles triangle, this side length is congruent to this side length. Now what that tells me is that the length, and I really didn't need to do all this, I'm just listing a bunch of information. But if I know that this angle theta, and we go across here, on a right angle triangle, this would be the opposite, and then this would be the hypotenuse. So remember that in SOHCAHTOA, one trig function in particular focuses on the opposite in the hypotenuse, and that would be sine. In other words, if I say sine of 30 degrees should equal the opposite, which is what I don't know, which is what I want to know, all over the hypotenuse, which is 12. If I take that same equation and I multiply it by 12, I get 12 times sine of 30 should equal my line segment length AD, which is technically the opposite side of this little triangle here, right? On a 30-60, the short side is 1/2 of the long side, right? So remember that on a 30-60 triangle, you don't even need a calculator for this. Remember that if this is 30 degrees, the ratios are 1x, 2x, and then the square root of 3 times whatever x is. So this would be equal to 12, divide both sides by 2, and I get x equals 60. Okay?